All right, so second half of week 4, we're going to talk about the sliding filament theory. And just a reminder that this is not completely accurate. Our understanding has changed a little bit. It appears that our muscles contract via something that's more of a winding filament theory, but we'll talk a little bit about that. We'll talk about that more a little bit later. But the sliding filament theory still gives a pretty good idea, or still explains, for the most part, our understanding of how muscle contraction occurs, and it's a little easier to visualize. So, what is it, and what do we need? That's really what we're going on. So, if you remember from our last lecture, actin and myosin have gotten together, right? So the dumb boy and my daughter are together. Okay, we call this the rigor state. All right, so remember calcium, and the way this happens is calcium enters the sarcoplasm. And this allows actin and myosin to bind, so we get the tight binding and or rigor state. So we're going to go through a series of steps. And just a reminder, something's going to happen with ATP, which is going to cause something to happen with actin and myosin. Okay, ATP is the cause, myosin, whatever happens to myosin and actin, that's the effect. So after they've tightly bound, they just kind of hang out there until ATP binds to myosin. So they've just gotten together, and now actin and myosin separate. Like, well, that seems silly. All right. So ATP binds, that causes a separation. What does ATP do? It breaks down, and it breaks down with an enzyme called ATPase. Okay. It's important to know that, and we'll talk, and I'll mention this in, I think, the next lecture actually, that fast muscle and slow muscle have different kinds of ATPase enzymes. Fast has a fast enzyme, slow has a slow enzyme. Okay. Now, when we break down ATP, one of the things that happens is we've got ADP and phosphate, which is cool, but we've also got energy released. And so this energy release causes two things, and they're kind of the same thing. The myosin head cocks, and actin and myosin bind. Okay. So we're here now. So next thing that happens is phosphate leaves. This causes the power stroke, so myosin pulls actin towards the M line. Okay, so we've got that there. And then after that, ADP is released. This causes that tight binding, and we're back where we started. Okay, so in order for successive muscle contractions to occur, we need a couple things. We need acetylcholine, and the reason we need acetylcholine is because that's ultimately the signal from the neuron to the muscle cell to say, hey, we're going to have an action potential. And then directly in the muscle cell, we need calcium and we need ATP. If we're missing any one of these things, it's going to be difficult, if not impossible, for successive muscle contractions to occur. Okay. All right. And so that is just your quick overview of cross-bridge cycling.